Geometry, Chapter 6 Review. We'll be talking about quadrilaterals, parallelograms in this unit. So let's review quadrilaterals. Quadrilaterals have consecutive sides that meet to form a vertex. So you'll have two sides that are adjacent to each other, and there will be a vertex in between them. So there will be a point in between. So your side would be JK and LK, and the point would be point K. Opposite sides have no points in common. So the opposite sides of quadrilaterals will not meet. They're not going to come together to in your drawing so that they share any points. Consecutive sides, we've already gone over. Those are the ones that show they're right next to each other and they have a vertice at the end point. You have opposite angles. Opposite angles are not on the same side of the quadrilateral. So J and L are opposite and K and M are opposite. And then you have consecutive angles, and the consecutive ones would be JK, and then another pair would be KL, another pair would be LM, and another pair would be MJ. So these are the basics about quadrilaterals. They're also two-dimensional figures with four straight sides. What we'll be dealing with for the most part will be the subsets of quadrilaterals, which are parallelograms. So parallelograms in general will have two pairs of parallel opposite sides. So take a look at this drawing. XW and YZ are parallel opposite sides. You also have another pair, which is XY and WZ, which are parallel opposite sides. The diagonals of parallelograms will bisect each other. So if you draw a diagonal from X to Z and one from W to Y, they will cut each other in half. Two pairs of opposite sides are congruent. So XY is congruent to WZ, and XW is congruent to YZ. Consecutive angles equal 180 degrees. So X and W, angle X and angle W, add to 180. Angle W and Z add to 180. Angle Z and Y add to 180. And angle Y and X add to 180. The sum of the interior angles of a parallelogram equal 360 degrees. So all four of the interior angles added together is 360. Each diagonal separates a parallelogram into two congruent triangles. So if I draw a diagonal from X to Z, we have triangle XYZ, and we also have triangle WXZ, which are congruent to each other. And I may have stated that wrong. Let me try that again. XYZ and ZXW will be congruent to each other. Let's get a little more specific, and let's talk about rectangles. So a rectangle is a parallelogram, but it's a special one. It has four right angles. Its diagonals bisect each other. Its opposite sides are congruent. Its consecutive angles equal 180, so angle F and angle I would be 90 and 90, which is 180. All four of these angles would be 360. And if I draw a line from F to H, I end up with two triangles that are congruent to each other. We have the rhombus. The rhombus is a parallelogram with 4 congruent sides. So think about sides when you think about the rhombus. You have 4 congruent sides. The diagonals also bisect each other. Opposite sides are congruent. Consecutive angles are 180. The interior angles are 360. And each diagonal separates the parallelogram, or the rhombus in this case, into 2 congruent triangles. So the important difference between a rectangle and a rhombus is a rectangle has 4 90-degree angles. The rhombus has 4 congruent sides. Let's talk about a square. A square looks a lot like a rhombus, except the rhombus is tilted. The square has 4 congruent sides just like the rhombus, but it also has 4 90-degree angles. And everything else that goes with the parallelogram also happens with the square, with consecutive angles, interior angles, and diagonals bisecting. Our next figure here is the kite. Now the kite is different. It has 2 pairs of congruent consecutive sides, but its opposite sides are not congruent. So you have to be very careful when you're working with kites. Segment LM here is congruent to segment LO, and MN is congruent to ON, but they are not all congruent to each other, and their opposite sides are not congruent to each other, which means their opposite angles of L and N will not be congruent, though in a regular kite M and O might be, but each kite will be a little bit different. Each diagonal does, though, separate the parallelogram into 2 congruent triangles. So, the kite into 2 congruent angles if it has congruent sides. The trapezoid, another special figure. It is a quad with exactly 1 pair of opposite sides. So it has opposite sides. In this drawing, it will be the top side and the bottom side, which we also call bases. So the bases are parallel. The sum of the interior angles is 360 degrees. For this trapezoid, it is not a regular trapezoid. It's not the next trapezoid we're going to talk about. So each side length may be different. Each angle measure may be different. Now we have the isosceles trapezoid, and let me correct my slide right now. It has the 1 pair of parallel sides. They're at opposite bases. And because they're opposite, and also we have some congruent sides going here. So let's show our marks of congruency. KH is congruent to JI. So, because KH is congruent to JI, we also have base angles that are congruent to each other. So, angle H and angle I are also congruent. We had 2 formulas in Chapter 6 that were very important. One was the formula for finding the sum of the angle measures of a polygon. So these are internal angle measures, and we discovered by making a table that if you had 4 sides and you cut it with a diagonal, you'll have 2 triangles, and that the sum of the measures will be 360 degrees. If you have 5 sides, you'll end up with 3 triangles if by drawing diagonals, and you'll have measures of angles of 540 degrees. Now this applies to regular polygons that have the same side length or congruent sides, and there's a formula that we can use to find this. It's the number of sides minus 2 times 180. So example, in this figure, a hexagon, we have 6 sides minus the 4 triangles, so minus 2 equals 4. I'm sorry, 6 sides minus 2 equals 4 triangles. 4 times 180 is 720. So remember that when solving for the sum or all the angles added up together in the interior of your regular polygon. Now to find just one of those angles in the polygon, we use the same formula, but we divide it by 2. So this is what it would look like if we had a decagon with 10 sides and we're trying to find the sum of the angles. It would be 10 minus 2, which would be 8 triangles, times 180, which is 1440 degrees. If you want to find one angle, one interior angle of a pentagon that has 5 sides, that would be 5 minus 2, which is 3 triangles, times 180, equals 540. But because we have to find each individual angle, we're going to divide by the number of sides, and that gives us 108 degrees. A problem that most of you had difficulty with was the division of transversals theorem. If you take parallel lines and then you go ahead and divide them by 2 transversals, there are a number of properties that result. But the first thing that I have to tell you is that these angles that you see, 3 and 1 and 4 and 2, are not congruent to each other. I say that again, not congruent. If you see the segment measure on one side of this transversal on the left side, as part of this theorem, it is actually set up so that you have 2 congruent segments. And you can see the congruent segment marks. So JK is congruent to KL. However, on the other side of the transversal, even though from transversal T, PQ is congruent to QR, PQ is not congruent to JK. So you cannot make that assumption unless they actually give you segment or hash marks showing congruency. So make sure that you're only comparing angle 3, angle 3, and angle 4 as congruent. And then angle 1 and angle 2 as congruent. Let's do some practice. We're going to find the missing values of this figure. It looks like it's parallelogram, but we do not know until we solve. So, finding the missing values, if you notice that opposite sides here both have y as a variable and x as a variable. So let's solve for the x's first. And by doing algebra, we set 3x minus 1 equal to 2x plus 3, and the answer is 11. I substituted in the first answer 3 times 11, which is, I'm sorry, the answer was 4. X was 4. I substituted the 4 for x, and 3 times 4 is 12 minus 1, which is 11, which is the answer for AB. To make sure that I've done this correctly, I solved also for 2x plus 3, and the answer was 11 for CD. So we have the correct answer. So x was 4, and our side lengths are 11. Doing the same for the y's, we discovered that the side length are 17. So if these two sides are 11, and BC and AD are 17, then we have a parallelogram. Find each measure in triangle ADG, and let's correct that, sorry. Triangle ADG, if C and E are midpoints of AD and GD. So let's look at this figure, and this is exactly what I was talking about before. We have C and B right here, and they have congruency marks to show that AB is congruent to BC. Now if you look on the other side of this figure, there are different congruency marks. So for GF, we have one congruency mark, and FE, we have another. So what does this mean? This means that even though these lines are parallel, the length in between each one of them is not. So find each measure of ADG if C and E are midpoints of AD and GD. So the measure of angle CED is what we're looking for right here. What do we know about this? Well, we know that CE is parallel to AG, which is 10 feet in length. And we know that we have this angle right here, which is GAD. And it's going to be congruent to ECD. Why do I know that? Well, we have transversals here, and we have parallel lines. So ECD and GAD are congruent, and they both equal 55 degrees. Now what we can do is take our triangle, and I'll go ahead and substitute a measure in here. And we can solve by subtracting 55 and 50 from 180. So 180 minus 50 and 55 leaves us 75 degrees. And that's our answer. And the measure of angle ABF, now that's this angle right here, it will equal 180 minus 55. Now 55 is not an alternate interior angle or consecutive angle or anything like that. What it is a supplementary angle. So angle GAD and angle FBA right here, or we can call it ABF, are supplementary, which means they equal 180 degrees, and 180 minus 55 equals 125. So another problem with the same drawing, we have CE, and one of the things we know about CE from back in chapter 4 is that CE is 1/2 of AG, and that was the triangle mid-segment theorem. It says the mid-segment of a triangle is parallel to the third side of the triangle and is half the length of the third side. So CE is half the length of the third side, which is AG. And AG is 10, so 1/2 of 10 equals 5 feet. And segment BF is AG plus CE, part of that same theorem, divided by 2 because it's in between both of them. 10 minus 5 divided by 2 is 7.5 feet. If you're not familiar with that theorem anymore, there wasn't a lot of practice on it. It's on page 194 in your book. Number 4, is this a parallelogram? Our first instinct is to say yes because it looks like one. However, no. We know that opposite angles of parallelograms are congruent, but in this problem we're only given one set of angle measures. To be correct and to be a parallelogram, this problem would have to show us at least one other set of angle measures. So it would have to say maybe 68 degrees right here, and then we would be able to say yes. Find each measure and I just jumped ahead to number 6. I'm not sure what happened to number 5, but don't go looking for it, it's not there. Find each measure in the rhombus. Okay, so you need to do this problem, you need to know what all the properties of a rhombus are. We want to find the measure of angle PQM. Well, one of the things that we know about PQM, that's this angle right here, is the diagonals of a rhombus are perpendicular, so they create right angles. So there are right angles right here. So PQM is 90 degrees. Continuing on, let's find the measure of QON, which is right here. Now we have information from our last step that we know about, and we can solve with that information. We also are going to be looking for QNO, and that'll be 7x. So let's start with QON. So QON would be an angle that's in a triangle. And to find that angle, we can take 90 degrees plus 7x plus 3x and equal it to 180. Solve our x's, and we end up with 10x equals 90, x equals 9, and 3x then would equal 27. And that is QON. it's 27 degrees. And to solve for Q and O, we would solve for 7x right here. And x equaled 9, we discovered in the last slide. So 7x, 7 times 9 equals 63. Find the measure in the rhombus, same drawing, and it's this segment right here, QP. Okay, well, one of the things we know about a rhombus is that the diagonals are bisected. So if this length, QN, is 2, QP will also. And now that we have the right slide, this will make sense. So if QN is 2, QP will also be 2. Trapezoid. Find the measure of angle A and the measure of angle B. So angle A and angle B. And one of the first things we can see is this is not a regular figure. Well, one of the things we do know is that consecutive angles in trapezoids equal 180. So to solve for angle A and angle D must equal 180 degrees. So 180 minus 34 equals 146. So the measure of angle A is 146. And the measure of angle B needs to be part of the supplementary angles B and C. So 180 minus 57 equals 123. And just to conclude, a reminder about two formulas, or one formula that's very important. The midpoint formula. The midpoint formula was the midpoint of 2 points. So for a midpoint formula, you'll have two sets of points. And you'll have a set x1, y2, and a set, and that should be x1, y1, sorry, and x2, y2. And this is the formula. x1 plus x2 divided by 2, y1 plus y2 divided by 2. There's going to be a problem that asks you to determine if a quadrilateral is a parallelogram. You'll need to find each set of points, which will be vertices of the quadrilateral, and then state whether the quad is a parallelogram and why. So just an example would be, after you've plotted all 4 points using the midpoint formula, you would say yes, and then you would say the diagonals are congruent and the opposite angles are congruent. If you had difficulty with that formula, go back in your book and review it and do some sample problems. Also look to see if you've got these problems right on your chapter review and chapter tests. The last two theorems you need to be responsible for. The hinge theorem: if two sides of one triangle are congruent to two sides of a second, and the included angle is larger of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second triangle. Just know in your head that if you have a smaller angle opposite a side, that side is going to be smaller than a larger angle opposite of a side. Triangle inequality: the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So those are very important to know. These should be intuitive, particularly the hinge theorem, just by visualizing. So if you get a problem without a drawing, make a drawing. Let's do a practice on that. Compare the given measures. Let's look at what we have in the drawing. We have angle ACB is 40 degrees, and we have angle EDF. Now, which is the larger angle? Well, EDF is the larger angle. So this EF is going to be a larger side than the opposite of this in this triangle, which would be AB. So AB will be less than or greater than EF. That's what you're going to be asked to determine. So do these problems and then go to your next slide. And there you have. AB is less than EF. Now they also had the measure of BCA. So that's this angle right here. And the measure of DCA, which is this angle right here. Is it greater than or less than? Well, let's look at the side that it's opposite. C is opposite a length of 5.5, and BCA is opposite of length of 5.5, and DCA is opposite a length of 4.4. So this side is going to be larger. So BCA is larger or greater than the angle DCA. So, once again, make sure you look at previous tests and previous chapter reviews to check for any problems that you missed. There are going to be a couple of links in an email for some of these problems in a Quizlet. I will send you those links. It has flashcards, matching games, and little sample tests that you can take. So if you need any help, please sure to contact me, and we'll see you in the next video.